So we're going to begin with our fancy little cup instrument. Now there are explanations for all of these. If you're teaching at the Science Spectacular at Pioneer, there are explanations for each of these activities, but I'll just talk you through them. For this one, you want to hold the cup to your ear, and you want to pluck it. Now, can you hear the sound that that vibration causes? Now what happens is I hold my finger down in different places. You want to do it?
Mm-hmm.
Okay, now when I pluck it, how did that change? This versus this.
It goes from a low sound to a higher sound.
Lower here to higher there.
Mm-hmm.
Okay, so as you hold the rubber band down at different places, you're changing the length of the vibrating rubber band. Now remember, once again, if you make it shorter, that vibrates faster, which causes a higher pitch sound to be heard. If the vibrating length is longer, then you hear a lower pitch. And it's really very pronounced when you hold it to your ear. You can really hear the difference. Do you want to try that?
Sure.
Go ahead and give it a go. All right. So we can also see this with our jars, with our bottles filled with different amounts of water. Now go ahead and tap those. Now first, wait, let's hypothesize. Which one do you think will have the highest pitch, and which do you think will have the lowest pitch?
I think that this one will have the lowest pitch and this one will have the highest pitch because this one has a more amount of space to have the sounds vibrate, and this one doesn't.
That is an excellent hypothesis. I want you to give it a try. See what you think. Go and tap it down here. It's a little louder. Okay. You know, it was the opposite of what you thought. You want to know why?
Mm-hmm.
Your hypothesis is actually totally correct if you think the air is vibrating. But what you're actually hearing on this is the water vibrating. So you actually had the right idea, but you were looking at it like the air was vibrating. Whereas actually what you hear when you tap it is the water vibrating. Now, actually, I'm really glad you mentioned that. For older students and for students that come up with such amazing hypotheses as that, you can actually show them that if I blow into it, kind of like a flute, now your hypothesis was correct. This one was a higher pitch, this one was a lower pitch. Because when you blow with the air, what you hear now is the vibration of the air. Whereas when you tap the bottle, there you go, you're hearing the vibrations of the water. So there's one little experiment so they can see it. Now once they've got that down, then they get to try and put these bottles in order of least to most water. All right, other example student, do you want to try, now that you saw the other experiment, I want you to tell me which one has the most water and which one has the least water.
Where should I tap it? There's paper.
Try a couple different places. That's probably a good spot.
Least
All
amount
right,
of
you
water.
think you're ready?
Greatest amount of water.
Let's see if you're right. Pull those up. That looks like the least amount to me. Oh, these two look close. Oh, I think we switched those ones.
Oh.
So you're pretty close. That was the least. So now that you can see it, you can switch it around a little bit. And try to hear. Now see if you can hear it better. There we go. Not bad. Good job. Good try. Right. And if kids are having a hard time, you can vary the amounts of water so the change is a little bit more extreme. You can even do just 3 bottles so that it's a little bit more obvious which one's the lowest, which one's the highest. For these older students, I decided I want to challenge them a little bit. Challenge not only their scientific understanding, but also their ear a little to see if they can hear the difference between the different pitches. So you girls did great. All right, so we have just a couple more experiments. We're going to do one more that relates to the length. Again, the shorter chimes. So we have chimes out for kids to just practice hitting. And listen to the difference. And again, realize that the shortest chime gives you the highest sound, whereas the lowest chime will give you the lowest sound. The longest chime will give you the lowest sound. And then to make it a little more fun, you get to try and figure out what the mystery song is. You want to try the mystery song? So follow the squares and hit them in order on the chimes. Should we move these up here so they work a little better? Okay, go ahead. Very good. All right, you nailed it. Good job. All right, so what was our mystery song?
Mary had a little lamb.
There you go. Mary had a little lamb. All right, now we have one more experiment. And this experiment focuses a little bit more on the fact that sound is a vibration. And vibrations, what's a vibration again? Show me a vibration in your hands. Something shaking back and forth, usually really fast. Okay? That's a vibration. Vibrations travel more easily through some materials than other materials. And this experiment is to help you realize that. So, you can take a guess. Which material do you think sound is going to travel the best through?
I think it's this one.
You think it's the air? That would make sense because that's how we hear sounds, isn't it? So that would be a really good guess. But let's find out. The way you find out is you put your ear on one of these bags, cover your other ear with your finger, and then tap gently on the table with this rock. So I'll show you. And then you move to the next material. There you go. You want to be listening especially for what you hear through the material and not in your other ear. All right, so go ahead. Go ahead and lay your ear down there. Tap more gently. Surprising, isn't it? Where'd you hear best through?
Probably this one.
Yeah, probably the dirt. The air, what do you want to try it, Nance? Give it a try. See what you think you hear best through.
Probably the water.
Probably the water. But what about the air? You can hardly hear it through the air, can you, compared to these two? This is actually a very surprising experiment when you do this yourself. I was amazed when I tried it how little I heard through the air compared to the others, when I feel like I hear actually rather well. So when you look at this, though, it kind of makes sense because dolphins and whales, other aquatic animals, they communicate through really, really large distances, don't they?
Mm-hmm.
Do you think they could communicate through those distances if they lived on land? No, probably not. It's not even so much their hearing ability, though it might also be a little bit better than ours, but it's more the medium that those vibrations are traveling through. That travels through the water or the dirt actually a little bit easier than it does for us, for the humans, through the air. So if another thing maybe for the parents around is if you see in the Old West movies, they put their ear to the ground to hear if a train is coming or if the horses are coming, and that's why the vibrations travel a little better through the ground than they do just through the air. All right, so that concludes the science of sound for Spectacular Science. Thanks for joining us.